All right, welcome. If you've ever found yourself staring at your AWS console, completely tangled up in security groups versus NACLs, well, you are definitely in the right place. Today, we're going to slice right through all that confusion with a really simple but powerful analogy that's going to make it all just click. So, let's dive in. So, here's our game plan. First up, we're going to meet our two security guards. Then, and this is the big one, we'll dig into the single most important difference between them, stateful versus stateless. After that, we'll see how they actually team up to create a layered defense, and finally, we'll give you a tactical playbook so you know exactly when to use which one. Okay, so to kick things off, let's just ditch all the technical jargon for a minute. Instead of thinking about abstract firewall rules, I want you to picture two very different security professionals who are protecting your cloud. On one side, you've got the bodyguard. This is your security group. Think of it as a personal bodyguard assigned to one specific server. It's smart, it's pretty permissive, and its main job is to check the guest list of who's allowed to come in. Then you have the Gatekeeper, and this is your network ACL, or NACL. This guard doesn't protect one server, they stand at the entrance to the entire neighborhood, the whole subnet. They are rigid, totally by the book, and they check everyone's ID on the way in and on the way out. Now, let's translate that analogy into the tech specs, because this is where it gets really interesting. Look at the scope. The bodyguard is at the instance level, right? Personal. The gatekeeper's at the subnet level, the whole neighborhood. And check out the rule types. The bodyguard only has an allow list, a guest list. But the gatekeeper, it can explicitly deny someone. It can say, nope, you're not welcome here. But the most important row on this whole chart, the real game changer, is state. And we're going to tackle that right now. Okay, this next concept is truly what separates our two guards. It is the critical difference, and it all comes down to just one thing: memory. Our bodyguard, the security group, is stateful. What does that mean? It means it's smart. It has a memory. So if your server starts a conversation by sending a request out to the internet, the bodyguard remembers that. It knows a reply is coming. And when that reply comes back, it's automatically allowed in, no questions asked. It's an expected part of the conversation. And look at how beautifully simple this is. Step 1, your server sends a request out. Step 2, the bodyguard recognizes the returning traffic and just lets it through. You don't need an extra rule. This makes managing your security so much easier day to day. Now, our gatekeeper, the NACL, is the exact opposite. It's stateless. It has zero memory. I mean, none. Every single piece of data, every packet, whether it's going in or out, is treated like a brand new stranger. It has no memory that the packet coming in is actually a response to something that just left a millisecond ago. So it has to check its rulebook for both directions every single time. And this is where people get tripped up all the time. If you create an inbound rule to allow web traffic on port 80, you must also create a separate outbound rule to allow the response to go back out. And that usually means opening a huge range of these high-numbered things called ephemeral ports. If you forget that outbound rule, your application just breaks. It won't work. So you might be thinking, okay, which one is better? But that's kind of the wrong question. It's not a competition. These two guards are on the same team. They work together to form layers of security, a strategy we call defense in depth. And the order they work in is absolutely critical. But before we see them in action, just a quick look at their logic. The bodyguard is permissive. It looks at all of its rules, and if just one of them says allow, hey, you're in. The gatekeeper, though, it's strict. It processes its rules in numerical order from lowest to highest, and it stops at the very first rule that matches. That's it. Whether it's an allow or a deny, that's the final decision. Okay, so let's trace the journey. When traffic comes in from the internet, the very first person it meets is the gatekeeper, the NACL, at the border of your subnet. If the gatekeeper's rulebook says deny, it's game over right there. The traffic is dropped and never even gets a chance to meet your server's personal bodyguard. But if it passes the gatekeeper's check, then it has to get past the bodyguard. And for traffic leaving your instance, the whole process is just flipped. First, it gets checked by the instance's bodyguard, which by default lets everything out. Then it travels to the edge of the subnet where it has to pass one final ID check from the gatekeeper before it's allowed onto the public internet. All right, that's enough theory. Let's get practical. This is your tactical playbook. When do you actually use each of these guards? So let's be super clear about this. For about 90% of your day-to-day security work, you are going to be using the Bodyguard, your security group. It's your primary go-to tool. The Gatekeeper, the NACL, is more like a specialized heavy-duty tool that you pull out for very specific, powerful reasons. So you're going to use your Bodyguard whenever you need to create that guest list for your servers. Simple things like allowing HTTPS web traffic, or maybe letting your application server talk to your database server. It's the perfect tool for managing access in a simple, automatic, stateful way. But when you need to bring out the big guns, that's when you call in the Gatekeeper. The #1 use case is blacklisting. If a malicious IP address is hammering your systems, the NACL is the only tool that can create an explicit deny rule to just block it cold. You also use it to enforce really strict network-wide policies, like I want to ban this risky protocol from this entire subnet, period. Let's just run through this quick cheat sheet. You want to serve web traffic. That's a job for the Bodyguard's guest list. Are you under attack from a specific bad actor? You need the Gatekeeper to deny them at the border. Need to make sure your app server can connect to your database? Bodyguard again. But what if you need to ensure no one can ever use a certain protocol in a whole subnet? That is a hard and fast rule for the Gatekeeper. So if you remember just one thing from this entire explainer, let it be this. Think of security groups as your bodyguards, managing a trusted guest list of who's allowed in. And think of NACs as your gatekeepers, enforcing strict, hard and fast border control for the entire neighborhood. And that really brings me to my final question for you. Now that you know the rules of engagement, now that you understand the very different roles of the Bodyguard and the Gatekeeper, I want you to take a look at your own cloud environment. Is your defense layered correctly for maximum security?